So the other day, last week, this was one of the assignments that we did. This was, which one was this? What? I don't have a title on it? I always put titles on it. Was it? I think it was day one. Day two is due today, right? Yeah, so this was day one. And I can't believe I didn't have a title on it. I always put titles. Anyway, there was a section where it said use a graphing utility. Okay, but I just said just use your graphing calculator. Okay, I'm going to show you a shortcut method now, but by using our graphing calculator on how we could do this question. So it says using a graphing utility to rewrite 5 plus 2i in the trigonometric form. That's what the directions were asking. And to do that, we had to find the absolute value of z, which is that r. And we had to find tangent, which you would do all of that on your calculator anyway. And then we would put that into the trigonometric form. So there's a different way of doing it on your calculator. So we're going to do, bless you, 5 plus 2i. Go to your calculator, and we're first going to go to mode. And you can maybe see where I'm hovering around the word real. You'll see right next to it is a plus bi. I chose a plus bi. So while you're in real mode, I want you to change it to a plus bi. And make sure you're in radians right now, so all of our answers match. Once you've set this, you can just hit second mode to get out of it. And then the original question was 5 plus 2i. So I'm going to type in 5 plus 2, and there is an I. It is second period or decimal point. And then from there, we're going to go under math. And we're going to move over to complex. And we're going to choose number 7, polar. Okay. I hit enter. Now I did not put it in the trigonometric form, but what it did was put it in that exponential form that was on the worksheet that is due today, that a lot of you hopefully finished already because it was very fast. I don't see many heads shaking.
You said it was fast?
Mm-hmm. The worksheet.
Oh, the worksheet.
Not the book, the worksheet. The worksheet was really fast. And you were just learning about this exponential form. Those of you that did it, what is this first number in front of E? R. And then what is this number up here with the I? Theta. Mm-hmm. And that's what we had to do for 27. Where'd it go? 27 was we had to find R and theta and put it into that trigonometric form. So it's not putting it into the form for you, but it is finding R and theta for you really quickly. So if it's a matter of time, you guys can use your calculator to, shorten your time a bit. And after doing the past 2 assignments, if you actually did the past 2 assignments, I hope that you now understand how to find the R and the theta, and using the calculator doesn't dumb you down at all, because we did so many examples in those last 2 assignments on finding R and theta. Okay. So just, try it with number 31. It's the same question. Just try it with number 31. The negative 3 plus I is the Z value. You can see my answers. Negative 3 plus I is the Z value. Trying to put this somewhere. Don't cover up everything, but negative 3 plus I, math, complex, polar, enter. And we get that 3.1623. Oh, I had 2 too. Ooh. I think I rounded wrong on that one. And then 2.8198. Yep, that's the top number there. Okay, so that's the first thing we're learning on our graphing calculator today. So when you're doing your worksheet, which you should have probably done already, you shouldn't be finding these values with the calculator. You can check them with the calculator if you'd like, but you should be doing them by hand. All right, next is our notes for today. That's not it. Did I just close it? I think I just closed it. Is there a way to like get something back? No, never mind. It's right here. So we used the thing on the calculator that said polar, but you guys haven't really learned what polar are, polar coordinates and equations. So we're going to do that today. Yay. I'm going to start out with just kind of a review from trig. Some stuff you guys should be able to tell me, no problem. Let's see. XY axis. If I go over X amount and then I go up Y amount, there's an ordered pair right here. I'm going to call that P, XY. What's this ordered pair right here? 0, 0, the origin, call it O. And then I would connect. And what would this line be? I heard R. I also heard hypotenuse, so we're just going to use R because that's like the higher level math, right? It is hypotenuse. But. And then what's this right here? Theta. Okay. What else did we learn when we were doing trig that uses X and Y and R's? What else did we learn? What, Christopher? Did you say something? Oh, looked like you were talking. What else did we learn? Nothing. What else did we learn that yell something out? Anything. What else did we learn when we were talking about trig and this stuff? SOHCAHTOA. So like what was cosine theta equal to? X over R, right? And what was sine theta equal to? Y over R. And what was tangent theta equal to? Y over X. So it's a good thing we're going over this, sounds like. Just taking, yeah, that's true. I do usually do sine first. I'm going to take these two top equations and just solve them for a different variable. I'm going to solve for X. So R cosine theta. And Y equals R sine theta. So up here, X is equal to R cosine theta. Y is equal to R sine theta. And we have our R. When we were saying that Y is sine and X is cosine, that was on the unit circle. But R means it doesn't have to be a unit circle. So that's why I have that number in front. Okay, now I'm going to take this picture and I'm going to overlay it with polar. So what polar is, it's a different set of axes. So we were just doing the real axis and the imaginary axis. That's different than the x-axis and the y-axis. So now we're going to do a third completely different axes. I'm going to set it, it's going to look just like that with the x, or it's going to look like the x and y-axis, but we're going to call them two different things. Well, it's actually one, but what we're going to do is we're going to have, let's see what color, blue. This one right here is going to be called the polar axis. And then this point right here is going to be called the pole. You've heard of a pole before, right? Besides like a pole, besides like a flagpole, let's think bigger. What kind of poles do you hear about? Okay, you got to speak up because this thing muffles big time. The North Pole and the South Pole, that's going to look like what we're doing today. I mean, you can just scroll down and see. Do you see those pictures? Doesn't that kind of look like the bottom or the top of the earth with the latitude and longitude and stuff? Okay. All right. Now, to write an ordered pair in polar, so I'm going to go and I'm going to write this ordered pair P, but I'm going to write it in polar. So to write it in polar, our first coordinate is R, and our second coordinate is theta. So really fat theta. So R is still going to represent the radius, and theta is the angle at which it is rotated around. And we've been doing this stuff for a long time. We've just not written it as an ordered pair before. So these are polar ordered pairs. I'll go down here, see if I missed anything. Oh, yeah, I know there's one thing I missed. It's in here, though. So R is the directed distance from O to P, the radius, and then theta is the directed angle counterclockwise from the polar axis to the segment OP. So it's going counterclockwise the same way we did in trig. Here we've got 3 different points. We're going to graph those together on these 3 graphs. The first one, I'm just going to copy it because I'm going to zoom in so I won't see it. 2 and then pi over 3. So I'm going to zoom in here. We're doing 2 pi over 3. So the radius is 2. Let's see, so I'm going to look at, there's a bunch of circles, and I'm going to look for the circle that has a radius of 2 units. So it's got to be this circle here that's 2 units out. Okay, that circle has a radius of 2 units. Then what I'm going to look for is the pi over 3 angle, which we should be pretty good at finding angles right now. I will let you know this one right here is pi over 4. This one's pi over 6. This one here is pi over 3 because it's not labeled, but I'll let you know. I already looked that up for you. I already figured it out. You're welcome. So we're looking for the angle, which is pi over 3. So that would be the theta there. So the place where they intersect is that point. So the R is telling us how far out, and the theta is telling us which angle. So question B is 3 negative pi over 6. So I'm going to look and I'm going to find the third unit out, which is a third circle from the origin, from the pole. Which ones go around the Earth? Is this latitude or longitude? Which ones go around? Latitude goes around. Okay, so there's the 3, and then we need to find negative pi over 6. So that's going to go this direction since it's negative, and that is this line right here. And where they intersect, that is where our point is. And then the third one, 3 and 11 pi over 6. Why don't you try that one without me walking you through it? 3, 11 pi over 6. See if you can do it. How did you do? Figure it out? Now, with polar, it seems pretty straightforward. Like we were able to get the exact same location in this top corner. I was able to get the exact same location in two different planes. One's the Cartesian plane, the rectangular plane, the Y and X plane, X and Y. And then the other one's polar, and we were at the same location. Polar has more than rectangular has, though. Polar can do a lot more, especially when you get to higher level math. I believe polar shows up in Calc 2. So those of you that are planning to get to BC Calc next year, this would be in BC Calc. Do you notice something about question B and C in the picture? They're the same picture. They're the same location. Can I have two different ordered pairs on the XY that are in the same location? Mm-mm. You have an X and you have a Y, and that's how you always get there. So polar gives you more options because there's different ways that we can get to that same point. The next is a graphing calculator thing. So let's take out our calculator again. And we're going to go to the mode. Let's go to our mode. And this time we're going to go down to the line that says function. And we're going to move over to put it in polar function. Okay, as soon as you have it in polar function, hit Y equals. Like we're going to graph something. Yes?
You want us to say okay,
Yeah, that doesn't matter.
does that change anything? Like if you stay in
I don't usually stay in it. I think it gives you eyes in your answers sometimes. So it actually might be helpful. We can play around with it later when I'm not doing the notes. Okay, what was I saying? Oh yeah, did you hit Y equals? Do you see there's no Y's? They're now R's. Okay, so for polar equations, we'll set them up as like R equals or theta equals. Just like instead of X equals or Y equals, we're going to set them up as R equals or theta equals. So it suggests let's graph R equals 3. So just type in 3. We are going to fix our window so it is a square window rather than a rectangular window. So if you, after you hit that 3, go to your window and you'll see that there are thetas on there and then there's X's and Y's. We're going to change the X's and Y's just so the window is looking at, is it -4? I don't have it open. Is the X's the 6's? Okay. So the X's are going to go from -6 to +6. And then the Y's are going from -4 to +4. And this just makes it so it's not skewed, stretched in one direction. And then you hit graph. It makes a circle. So what we're graphing right now is all values where R is equal to 3. And R is the radius. So if you talk about a place where the radius is always 3, that's going to be a circle. Theta was not in this equation at all. So it's like having a 0 theta there. So 0 times anything is not going to matter. So any theta is still going to give us 3 for the answer. It's a circle. Now, what I want you to do, and I can't really model this on the calculator on the computer because it goes really fast. But what I want you to do is I want you to change it to a -3. Watch how it graphs. Change it back to a +3. Watch how it graphs. Could you tell a difference when you did it? What happened with -3 different than +3? Emily? It started at -3. Now, did it go the same way that +3 went, or did it go the opposite way? Went the same way. Both of them are going counterclockwise. It's just starting at a different location. Before we go on, it also says use trace to see if we can find the ordered pair 3, 5 pi over 4. Okay, to find the ordered pair 3 and then 5 pi over 4. So if you hit trace, see if you can move that little bug around until you can find 3, 5 pi over 4. Which quadrant should it be in? 5 pi over 4. Which quadrant? Louder. Third. Okay. How are you going to know which one it is? Huh? Somebody tell me what he's saying. I can't understand him. Oh, the X and the Y should be the same? Okay. So that's got to be it, right? What should the X and Y be? If we're at 5 pi over 4, if we're at 5 pi over 4, Peyton, what should the X and Y's be? For both, yeah. Oops. Is that what your X's and Y's were? Christopher, why are you telling ×3? Why are you saying that? Because that's radius. And when we were doing like square root of 2 over 2 and negative square root of 2, those were just for the unit circle when we got those ingrained in our heads. This isn't a unit circle. It has a radius of 3. So if I took that times 3, you can see that that is the decimal. So you should be able to find it. Might have to know what the decimals are. Okay, going back to the notes. So what we saw on the first page is that there can be multiple representations, multiple different ways of writing the ordered pair for the exact same location. So we're going to actually find some of those different ordered pairs. What you saw when you did this calculator part is you saw, you know, if I graphed it starting at 3, and let's say I went over to that ordered pair 3, 5 pi over 4, or if I graphed it starting at -3 to get to 5 pi over 4, I can still get there. Like I can get to that same location from either of those starting points. So there's different ways of writing the ordered pairs. Of course, you can just add 2 pi and go around again, or subtract 2 pi and go around again. So that's saying right here, if you use your same R and you take your theta and add or subtract 2 pi as many times as you want, you can get other ordered pairs. Or, so this is kind of new, if we take negative R, which is like taking the -3, and then you're going to add or subtract 2 pi or 2n plus 1 pi. What is this? Who knows? 2n plus 1. Who knows what that is? That's something in math that occurs a lot. Anybody know what that represents? You know? It's the odd numbers. Very good. Nobody knew in my first spell. It's the odd numbers. So if you weren't sure, you could plug in any number. 0 times 2 plus 1 is 1. 2 times 2 plus, or 1 times, I can't do it. 1, that'd be 3, and so on. Okay. So you could add odd pies onto negative R, or you can add even pies onto positive R. So here's 3 negative 3 pi over 4. Let's find that on the graph. 3 is going to be the third circle. And then negative 3 pi over 4. So we're doing pi over 4s. We're going in the negative direction. Oops, this one here. And where they cross is that polar coordinate. So that'd be like I'm starting at 3 and going down and around negative 3 pi over 4 to get there. So we want to write it 3 other ways. So I could add or subtract any value of 2 pi. I'm not going to get carried away and crazy. I'm just going to add 2 pi. So that would be 3 comma what? 5 pi over 4. Now let's just go to the graph and make sure that makes sense. If I'm at 3 and I go 5 pi over 4, that's positive. So, yep, that makes sense to go 5 pi over 4 to get there. We could also do negative 3. So we could use the second equation. And we can take any odd value of pi. We could add or subtract it. So let's just add pi. So if I have negative 3 pi over 4 plus pi, what do we get? Pi over 4. So if I'm starting at negative 3, here's negative 3, and I move pi over 4, that works. And then how about negative 3 pi over 4 minus pi? Just subtract pi that time. Eden, can you tell me what that is? Thank you. So if I'm starting, excuse me, if I'm starting at negative 3, then I would go negative. That's going to be the opposite direction, all the way around, almost all the way around. 7 pi over 4 around. That's this part. So that would also end up in the same place. And there are infinitely many answers, but I'm not going to get carried away and crazy. I'm just going to do like easy ones when I do my work. So maybe any questions so far? Okay. Make sure you ask, because I know, well, unless you like do other math outside of what we do in school, you haven't seen this stuff before. So coordinate conversion, if you're given a rectangular ordered pair, which is x, y, and you need to put it in polar form or vice versa, we can use any of these equations to kind of help us, or these relationships to help us. And here's another relationship as well. R squared equals x squared plus y squared. Tangent equals y over x. Cosine theta is x over r. Sine theta is y over r. That's stuff that I was doing in the front page. And by the way, never mind. So that picture that I drew on the front page before we even started getting into here, that's this picture right here. We've already drawn this picture. And then these 4 formulas we already wrote on the front page, except for I can't remember if I wrote this one. Did I write this one? I don't think I wrote that one out. This here is the equation of a circle at 0, 0, the center at 0, 0, with a radius of r. So that's the equation of a circle. That you know, we've definitely seen these things before, but we haven't really seen polar. I mean, that's how we found ours. We did that formula, but I don't think I wrote it on the first page. Okay, so we're going to convert 2 pi into rectangular. So as I'm converting, if it's an easy one, I also like to visualize. 2 pi. So 2 would be the second circle out. And then pi would be over there at 180 degrees. So that's that point in polar. We're going to write that in Cartesian or in rectangular form. Does anybody know the answer already before I even write it? It's negative 2, 0. That's the answer. Let me show you how we can get it if we couldn't graph it easily and figure it out. So what we could do is we could say, well, x is equal to r cosine theta, and y is equal to r sine theta. And that came from trigonometry. You've already learned. It was in the box right above it. R is 2. Cosine theta is pi. So cosine of pi is negative 1. And so I get negative 2 for my x value. And then 2 sine pi is going to be 2 times 0, which is 0. So the ordered pair is negative 2, 0 in rectangular form. Okay. The next one. So this one might be a little bit more challenging to picture because, like, what's the square root of 3? Is it 1.73? Is that the one that's 1.73? Yeah. So it's, you know, somewhere around here. And we're sitting at the pi over 6. So that's at least easy. I'm going to use these formulas. We're going to have x equals r cosine theta. So our x is going to be radical 3 cosine at pi over 6. So square root 3 cosine at pi over 6 is, come on guys, cosine pi over 6. I mean, we still have to know those. 3/2. And then y is r sine theta, which is radical 3 sine pi over 6. So radical 3 times half, square root of 3 over 2. So the order pair for this one is 3/2 square root 3 over 2. And you could figure that one out by a picture as well. You just have to be, you have to really think about the picture, but you could figure it out from a picture. This would be pi over 6 is 30 degrees. And then we know that this side would be radical 3 of a what kind of triangle? 30, 60, 90. So the 30 would be like x. This one would be the x radical 3, and this one would be the 2x. So you take this one, you do radical 3 divided by 2 to get it. Yes, Philip. Well, if you put in your calculator, you're not going to get a radical. Sorry. So would it be easier to push buttons than think? Some people, yeah. I mean, there's definitely shortcuts that you guys can use your calculator for, but I don't know. When I went to college, by Calc 2, we weren't allowed to use our calculators anymore. So Calc 2, Calc 3, we weren't even allowed to use our calculators. So, like, I want you to learn the calculator stuff, but I don't want you to be dependent on it. Not for this level of class. Okay. This section, example 4, we're going to convert these points, which are x, y, to polar coordinates. So we're going to do this a little bit differently. Okay, so to get, sorry, I'm like having trouble talking. These are x, y right now. We need to get r theta. So now let's compare it to the stuff we have been doing for a while. How do we get r? Yep. We do x squared plus y squared, square root of that. That's going to give us our r value. So we will do square root of -1 squared plus 1 squared, square root 2. There's our r value. And then how have we been getting theta lately? All right, so we're going to do tangent inverse of, we're going to put y over x. Now, remember with this, if you look at my answer keys, I'm always like drawing, where's -1, 1? I just want to make sure I have the right quadrant because there's 2 places. So what angle would this one be? What would theta be? Yeah, 3 pi over 4. Oh, and we're done. We just have to write as an ordered pair now. Whoops. When I'm zoomed in really fast, I have no control on that thing. So there's our polar coordinate. Same location as 1 or -1, 1. So for question B, same thing. So we'll do 2 squared plus 0 squared, or other way around. So I get r is 2. And then theta, I'm going to do tangent inverse of 2 over 0. Now, I am writing this tangent thing down, but I already know the answer by looking at the picture I drew. What's theta? I don't like to be this person, but if you are playing on your phone right now, it's not an appropriate time to be playing on your phone. You should put it away. You should be taking notes. Thanks. Okay. All right, and then there's some pictures here where you can see both of those are graphed at the same place. I like copied all the pictures from the book so we didn't have to draw them, but I did want you to be able to see them. And then equation conversion. This one's kind of cool, this example that they have right here. Say we were taking the equation y equals x squared. You guys know what that looks like, right? Yeah, parabola. Where it like starts at 0, 0, or the vertex is at 0, 0, I should say. And then we're going to change that into polar by using the fact that x is equal to r cosine theta, and that y is equal to r sine theta. So that's what they did, is they substituted for x and y. And then they solved it for r. So there's some identities and stuff going on here. But they solved it for r. And this is what they got. Now I want us to graph that equation so we can see it looks like a parabola, just on polar form. So let's go to our graphing calculator. Y equals, and we're going to do secant times tangent. Secant theta times tangent theta. How do we type in secant? 1 over cosine, 1 over cosine. To get the theta, I'm about to push the button and it will turn red. It is the same button that I use for x. That's how you get theta. It just automatically changes that button into whatever like the input is for your graph. When you graph it, pay attention to how it graphs it, because it doesn't graph it the way that you'd normally graph a parabola. Well, the way the calculator would normally graph the parabola. It's too fast for you to watch it on mine, but like goes from the center up and then from the left down when it does it. Why do you think that is? Why doesn't it just go left to right? Because that's the polar is a big circle. We're talking about the radii and we're talking about the angle rotating. So it's using the angles to determine where it's graphing and stuff like that. Okay. So here we're going to convert polar equations into rectangular form. So actually, right before we do that, I just want to talk about rectangular form for a second. This is where some people had questions in my other class, so I'm going to try to have you guys understand, excuse me, before I get to the questions. You know, if we have a rectangular graph, y equals 4, what does that look like? Horizontal line at 4. So y equals 4 does have an x in it, but we just don't write it because what's the x that goes in it? 0x. It has a coefficient of 0, so you never see the x, but you really can plug in any value of x and you're still going to get 4. And same thing if I have like x equals 2. There really is a y in there. Okay. So when we see this equation, this first polar equation, r equals 2, they're telling you nothing about theta, but the equation could be written as r equals 2 plus 0 multiplied by theta. And that's going to mean that theta is not going to matter. Theta can be anything. So all I know about this is the r is 2, and the r is the radius. What kind of figure is it if r is always 2? Okay, so I copied the picture from the book. It's already graphed for you. Here's a picture that shows us where r is already 2. This is all the place where r is 2. So that's the graph of r equals 2. We need to write that equation rectangular. So I'm going to use things that I know, relationships that I know that go with polar and rectangular, and that one relationship has to do with r. R squared is equal to x squared plus y squared. That is a relationship that connects the r and the x and the y's together. And I do know that r is 2. So 2 squared is equal to x squared plus y squared. So x squared plus y squared equals 4 is the equation of a circle that has a radius of 2 in rectangular. So I have x and y. This is in rectangular. I don't have an r and I don't have a theta. This is rectangular. Okay. The next one, we have theta equals pi over 3. So that means, there's like a 0 r in there somewhere. So the r can be anything. So r doesn't matter. The pi over 3 is the part that matters. So we're thinking about ordered pairs where the angle is at pi over 3. Ordered pairs where the angle is at pi over 3. So they have a picture. You can't visualize it. They do a picture. I went too far. So here we've got ordered pairs, a bunch of them lined up, where the angle in polar, the angle is pi over 3. But the r doesn't matter. So what does that look like in rectangular? It's a line. So when we're done, we're going to have the equation of a line written down. Okay? So I'm going to think about a relationship that I know with theta and with x and y. I know that the tangent of theta is equal to y over x. That's a relationship that I know that goes between theta and x and y. And theta is pi over 3. So the tangent at pi over 3 is equal to y over x. Patrick, what is the tangent of pi over 3?
That's just square root of 3, right?
Now you can see that I do not have a theta anymore. We have x's and y's. This is rectangular, but it's not really in the form of a line, the way it's written right now. So I'm just going to multiply both sides by x. And then we have y equals, this would be our m, x plus, and then we'd have 0 for our b value. So this would be the equation. Okay, and the last one is not as easy to kind of visualize. Like those two were kind of easier to visualize. So r equals secant theta. That's going to depend what the thetas are. We have to do the secant at each theta that you would plug in. My phone always thinks I'm talking to it. And then that would give you the r value from there. That would give you the radius from there. So this one's a little bit more challenging to do. I mean, you could try some thetas. I'm going to show you how to change the equation around, but just talking about that graph down below, we could try some thetas. What would be r if the secant is 0? What would r be? 1? So you could see that's on there. I forget what else they said about this. I'm sorry. Okay, so what we can do for this one to change it into the other equation is we can, again, look for a relationship that helps us put x's and y's into it. So for this one, r is by itself. And secant theta, we know, has to do with cosine. So what they chose to do is they used the equation r cosine theta is equal to what? X. And they're using this equation over here, this equation right over here. And they're saying, here's what r equals. Oops, I went too far. Here's what r equals. Let's plug it in. Okay. And what's secant times cosine? Sanjay, we're going to ask you a question or just answer. We're going to say 1. So that is how they have the graph of x equals 1. They had to play around with that and use a trig identity. Okay. Now that's the notes that we had. And then when we were working on our assignments, we realized there's something that the book did not tell me. So I didn't put in your notes, but we're going to add it in our notes right now. Okay. So this is an extra example here. It was to use the graphing calculator to find one set of polar coordinates at the point given in rectangular. I'm not going to write all that. Use graphing calculator to change this XY to polar. And then I'm just going to, this is going to be number 28 from the book. You have to do 27 and 29. So I'm going to do 28 from the book. And this is just a graphing calculator question. Okay, graphing calculator, you ready? Or are we still writing down the directions? Nobody's answering. Ready? Okay. She's ready, so. Let's go second mode so we can get to the calculation screen. And when I was doing this earlier, it didn't matter what mode I was in. So we're going to find out right now if it matters what mode we're in. It didn't earlier. We're going to do second, and then you're going to go to angle. And then you'll see 5, 6, 7, 8. 5 says we're going to take a rectangular ordered pair and change it into the polar, but you're just going to get the R. 6 is take a rectangular ordered pair, change it into polar, but you're just going to get the theta. And we need to get R and theta, so we will use 5 and 6, just not at the same time. So I'm going to go back up to 5. I'm going to hit enter. And we're going to type that ordered pair in, which was, I don't remember. What was it? Thank you. -5. And then there is a comma button too. And then you'll hit enter. It's next to parentheses, above the 7. Okay, and then I'm going to do that again, but this time I'm going to choose the polar theta so I can get the Y value. So second angle, 6, -5, comma 2. Now, I'm pretty sure, I didn't double check it, but I'm pretty sure if you were in degree mode right now, it would tell you a different number for the angle. Pretty certain it would, but I haven't checked it. But that would be the 2.76. That's in radians. So we would write our ordered pair as, oh, it's not going to be 5.3852. And 2.7611. So now if you get a bunch of decimals, that is a calculator question. If you're asked to do it without the calculator, probably going to get like radicals. Okay. If you guys have any questions, definitely feel free to ask. One more thing I wanted to say before we start. If you didn't read it yet, this is what I should have talked about, but I didn't because you guys were at your locker. We're going to have a short quiz on Thursday. It's going to be on 6.5. We spent a few days on 6.5. We're going to take a small quiz on it. The quiz will cover the material, 6.5 day 1 and day 2, and that worksheet. If you want to have extra practice, I suggested some questions from the book. This is optional. It is not mandatory. Your quiz will be on Thursday, so if you want to, do some of that Wednesday night or Thursday morning during XH or something, just to make sure you're ready, you could do some of it, but it's optional. And then our polar assignment is due on Monday, so that won't be due next class. It'll be due on Monday. Okay. You guys have the rest of the time to